Hello, good morning, everyone. Good morning, Smith. Can see you.
Good morning, sir.
Good morning. Good morning. Today there are very few students online. Anyways, today I thought of actually on that day I could not have the connectivity. I tried, but somehow it did not work out. And therefore I conveyed the message that I'll be taking at 10 and I'll be finishing this unit with you today. There are only 17. Anyways. So I'll just start with, I'll just show you my presentation first. Yes. Can anybody tell me where we stopped last time, last Wednesday? We completed with protein precipitation.
Sir, this was not done.
This was not done. Okay, this was done.
Yes, protein precipitation was done.
Okay. Thank you. Just very quick revision of what we did last time, or rather up till now. We have studied the importance of liquid extraction as a sample preparation technique. We also have some idea about Craig's countercurrent extraction, which is nothing but multiple extractions used for separating components which have very similar partition coefficients. One major advantage of that. And then we understood what is accelerated extraction. Basically, it's a closed system extraction. The important considerations in accelerated extraction is to reduce time, maintain the efficiency, and boil that sample or heat that sample above the boiling point of the solvents which are used. Then we talked about a very important extraction technique that is known as micro-assisted extraction. The main crux of that extraction is that we want to again reduce the time, we want to maintain the efficiency, and we want to minimize any other processes other than the desired process in micro extraction. And the major difference between that and the other technique is that it is diffusion controlled and the heat and mass transfer occur in the same direction. So these are some of the salient features of these techniques. And then we studied, of course, protein precipitation, which is not essentially extraction technique as such, but yes, it is used exclusively for biological samples, and that too to remove proteins from biological samples. And it is a very simple and quick technique which can be afforded by using acetonitrile, common organic diluents like acetonitrile, methanol, sometimes acids as well, but in very small volumes, Uh, for acids specifically, trifluoroacetic acid and perchloric acid, 10 microliters, 15 microliters, 20 microliters of say about 10% or 20% solutions of these acids are also being used. Then we move on to a technique which is very, selective. See, I've always emphasized on the word selective during my lectures in semester 1 and now as well, that whatever work that is being done through any process, through any instrument, for any type of analysis, whether it is structural analysis, whether it is quantitative analysis, whether it is qualitative analysis. See, one thing is very important in analysis or in analytical science is selectivity. Sensitivity, I would put it at number 2 for the simple reason that when we work with, as I said, real samples, unknown samples, then selectivity dominates when we compare it with sensitivity. Sensitivity can be achieved. I mean, it is better, or it is worthwhile to achieve sensitivity when we have a single analyte, and then we can improve our techniques or methodology to have a good sensitivity. But as far as selectivity is concerned, that is one major criteria on which current science is based. One of the major criteria which selectivity is one of the major issues. And catering to that need, solid phase extraction is one such technique. Now, what is the difference in the solid phase extraction and the techniques which we have studied up till now? Again, it has two phases. One is the liquid phase and the other is the solid phase. And we know that it is not simple to work with solids because of the inherent heterogeneity in these samples. So sample cleanup or extraction is a prime requirement for complex samples, complex matrices. So the limitations which we found in LLE are largely overcome by the use of SPE, and it is used for sample cleanup and concentration. This is important. It is used for sample cleanup. That means you clean up the matrix and pre-concentrate the sample. So this is where SPE predominates the other technique in terms of efficiency. That means once we separate or extract our analyte using solid phase extraction, the extracts are much cleaner. They are very clean samples which are devoid of any unwanted, extraneous substances in our extracted sample. And in this technique, the solid thing, because as I said, it has a solid phase and it has a liquid phase. Liquid phase, of course, will be our sample, and because as such we cannot analyze any solid, we need to prepare its solution. So looking into that, what we find is that the solid phase is a very important aspect of SPE. And in this technique, hydrophobic organic functional groups are chemically bonded to solid surface. Now, what is this? What is this solid phase in solid phase extraction? See, as we studied in LLE, we can extract cations, we can extract organic molecules which are, covalent, essentially covalent in nature, from aqueous phases, right? This is what we used to do in liquid extraction. Now, to extract these constituents or samples which contain organic moieties, those which have organic or covalent bonding or organic compounds, they are essentially, we know, are water insoluble and they are hydrophobic in nature. By and large, majority of 90% of the compounds which you come across in organic chemistry as such are water insoluble. There are very few compounds which are soluble. And essentially they are hydrophobic in nature. So to extract those molecules which are hydrophobic in nature from a complex matrix, we need a solid phase which is hydrophobic in nature because of hydrophobic interaction. And this is achieved by using silica, powdered silica as a solid phase. If you look at the structure of silica, it is a very, three-dimensional structure with free selenoid groups, Selenoid groups are SiOH. These are the free selenoid groups in the solid phase in SPE. Now, if when we say that it should be hydrophobic, but essentially this is hydrophilic. These OH groups can be ionized. So definitely silica needs to be chemically modified. Silica, as we know, is one of the most widely available material with us, and it is relatively inexpensive. But unfortunately, it is it is highly ionic. I mean, it is also not, we say it is not very stable as well, and it can readily give its H from OH and become a charged species. And the moment it becomes charged species, it will be difficult to interact or retain organic molecules. And therefore, there has to be some modification. Into the structure of these molecules or these substances, so that they become, responsive towards hydrophobic substances or organic molecules. Now, in an effort to do this, what is being done? That selenoid groups are chemically reacted to form long linear hydrocarbon chain. That means the structure would be SiO, then CH2, C18, 18 carbons, and at the end you have CH3. So basically, you are trying to modify the structure of silica in such a way that it becomes non-polar. Silica as such is highly polar. Bare silica is highly polar. So you make it non-polar. At the same time, you make it hydrophobic in nature. So the common bonding which you find in silica is of C18 chains. And then they are made into a very small particle size of 40 micrometers, 30 micrometers. Now with advancement in technology, people have made particle size as low as 1.7 micrometers to reduce the particle size, which has C18 chains. But in solid phase extraction, we use around 30 micrometers or 40 micrometers size of these particles, which are chemically bonded. And how they interact with organic substances? Through van der Waals forces and many other forces, which we will see as we move ahead. So by hydrophobic interactions, and just like van der Waals interactions are some of the weakest interactions you will come across. They are present everywhere. I mean, very weak van der Waals interactions is even present in gases. So we can understand that it is obvious to say that it will be present in liquids and solids as well. These are one of the most weakest forces available, which we have studied, van der Waals forces. And that is what is one of the forces which is responsible for retaining organic substances on silica, which is bonded with, chemically bonded with C18 chains, carbon chains, C18. Now, when silica is bonded with a hydrophobic phase, they become waterproof. Now, they are no more affected by water. Otherwise, in water, they simply dissolve to some extent. So there is a problem of stability. But if we make it C18, we attach C18 chain, then it becomes hydrophobic and at the same time it becomes waterproof. Now the question comes, if we have any sample in an aqueous phase, real sample in an aqueous phase, it will just not mingle with that liquid phase because it has become waterproof. Now, to overcome this problem, what one does is they try to activate it before the process of extraction. And this activation is done using methanol as the solvent. Why? Because methanol is something which acts as a bridge between the hydrophobic characteristics of the solid phase and it is at the same time miscible with water. So it tries to, create a condition in the extraction phase such that it allows water to enter. Otherwise, water cannot enter. So we have this problem once we make it waterproof, that it should be, it should be able to take in aqueous phase as well. And then this whole process of adding methanol, etc., is known as conditioning. So conditioning is very important, step in SPE for extraction. Now this is how the selectivity is achieved. I'll just make it a full screen here just to show you. Oh, yes, because this has two things to be shown in the same slide. Selective retention and elution of analyte using solid sorbent under specific conditions. Now this is important. Solid phase extraction doesn't work as such. You need to create specific conditions of solvents, solvent systems, pH, additives, etc., etc. So there are many things which we need to first optimize before we go or to achieve selective retention. Now, as I said, the mechanism of retention or adsorption on this solid phase involves ion exchange mechanism, hydrophobic retention, hydrogen bonding, van der Waals interactions, and ion dipole interaction. These are the forces which dominate in solid phase extraction to retain molecules which are essentially covalent in nature or organic molecules or large molecules, bulky molecules. And this is how it works. Now these are known as extraction cartridges. These are made up of, a polymeric material. These extraction cartridges are made up of polymeric material, a very simple cartridge, which has a small disc here, you can see at the bottom, just to hold the solid phase. This is the solid phase, the silica phase, C18 phase. So, and these are the different steps which one needs to carry out for solid phase extraction. This is silica base, and then you have your sample which contains your desired analyte and other substances, unwanted substances as well. So you apply, you first condition, then you apply your sample to the extraction cartridge, and then of course you try to elute the unwanted things first. You try to elute unwanted things first. So that means you use different solvents or solvent systems to remove the unwanted things. So here what you do, you can use any solvent, one solvent, two solvents, aqueous plus organic solvent mixture. You can add, a small amounts of additives like acids and bases, and somehow this needs to be optimized depending upon the matrix which is there in your sample. So आप एक एक करके इसको अनवांटेड चीजों को आप इसमें से इल्यूट करते हो, एंड देन once you are convinced that beyond this point nothing can be eluted, then you start to elute your analyte of interest. So in the last stage you get in the elution your analyte of interest using a very suitable optimized solvent system. Very suitable optimized solvent system. So this is the whole story of the silica, which is used as a stationary phase, which is chemically bonded in the form of C18 chains to retain hydrophobic substances. And if you look at this slide now, what you find here is that instead of silica, sometimes now the technology has advanced to such an extent that instead of using silica, they have started using polymers as the stationary phase material or as the solid phase material. Of course, when you make a polymer out of it, a cross-linked polymer out of it, it will have some degree of porosity. There will be some pores, and that this process of extraction needs to be suitably optimized using suitable solvent systems, such that the analyte which you can see here is retained and the unwanted things are eluted out. And then again, this has the same steps: loading, washing, and elution. Elution will finally lead to your analyte of interest separated from the matrix. Washing is to elute the unwanted things, and loading means when you apply your sample to your stationary phase or the solid phase. Now these are the operation steps. These are the 4 principal operation steps which are to be performed in SP. SP is not as simple as a protein precipitation, but it does much more. But the thing is that it is slightly on the expensive side when we compare it with liquid extraction or protein precipitation. But the efficiency with which it extracts the analytes of interest is much higher as compared to the LLE and protein precipitation. And these are the following 4 steps which needs to be followed for any SPE operation or extraction. The first step is conditioning. The second step is retention. That means conditioning with methanol. This is one of the most widely used solvent, methanol, for conditioning. Retention or loading. That means you load your sample. So that it gets retained on the sample matrix, on the stationary phase matrix. And then you rinse or you wash. Rinsing or washing, one and the same thing. You wash unwanted things. Or you remove unwanted things by using a suitable solvent. And then finally, you elute the desired analyte using a suitable solvent system. So these are the 4 steps which one needs to follow. But of course, you need a lot of method development prior to developing a very stable and SPE extraction methodology. One needs to do a lot of method development before we arrive at for a particular sample. So this is a prime requirement, but these are the 4 steps which needs to be followed every time whenever we do SPE. Now, if we move ahead, what we find is these are the interactions, as I said, which are dominant in SPE. Solid phase extraction utilizes non-polar, polar, and electrostatic interaction. It all depends upon the type of solid phase which we have used, because it can be chemically modified. We have just talked about C18 chains, and if you look at the on the left hand side, what you find is there will be weak forces. These are the chains. These are the chains. So it will interact hydrophobic interactions or van der Waals interactions between the chains and the structure and the of the analyte. So these are the analytes and these are the chains which are coming out of the silica base. These are the hydrophobic chains. So there is one type of interaction which is known as van der Waals interactions. Then one can chemically modify this chain as well, so that they come out with hydrogen bonding with the analytes. So as you can see in the second example, hydrogen bonding is responsible for retention in some of the cases. Once, of course, you modify this chain. This chain can be modified now. If you look at the commercially available SP cartridges, you will find hundreds and hundreds of materials which are being used now, involving different kind of interactions, non-polar, polar, and electrostatic interactions. And if you look at the third example, what you find here is that you have a positively charged, analyte, and then you need to create a negatively charged species in the solid matrix. That means the stationary phase matrix or the solid phase. So it is negative SO3 negative, and this is NH3 plus. And this interaction is known as electrostatic interaction. So these are the principal, forces of interactions which happen in SPE, and they are responsible for extraction. Now, so that was all about SPE, conventional SPE. Now, with advancement again in technology, there are hybrid SPE. That means higher version of SPE, which removes phospholipids. Now, what are phospholipids? We know proteins, right? And we know lipids. We know we know proteins and we know lipids. Now, when we are working with biological samples, we will always find proteins, fats, or lipids, or even carbohydrates, even salts, even ions in any biological sample. Biological sample matlab it can be human whole blood, plasma, serum, urine, tissues, cerebrospinal fluids, so on and so forth. So any body, fluid or matrix which will be containing to some extent proteins and phospholipids. And to remove these two using solid phase extraction is known as hybrid SPE. So you are able to remove phospholipids as well as proteins in hybrid SPE. And these are the cartridges which you can see. These are commercially available cartridges. These are not simple cartridges. These are expensive cartridges. And these cartridges are different from the SPE, conventional SPE, which we just saw in the previous discussion. So these have, again, you can see here, they have this material here, the solid matrix here, which is the solid phase here, in these cartridges, very similar to SP. And this can be performed simultaneously for 96 such cartridges. So this is a tray which has 96 wells here, where you can do simultaneous extraction of 96 such tubes, such cartridges, and that is commercially available, and it provides very consistent response, and it is widely used for removing proteins as well as your lipids. And phospholipids, as I said, they will contain a phosphate group. So phosphate group is more water liking, water soluble, whereas the other things which are present in your sample would be more of a hydrophobic kind of a thing. So that is what is utilized here in hybrid SPE. So that is what I just said is written here. These cartridges allow for easy processing of just one or few samples at a time, but with advancement in technology, one can use 96 well plate, as we just saw, a tray which can hold 96 such cartridges. And the most important aspect is that in biological samples you don't work with very large volumes. आप कभी किसी का blood 20 ml 30 ml नहीं लेते, you hardly take 1 ml 0.5 ml. So these cartridges are designed to hold, I mean, volumes as small as 1 ml 1.5 ml 0.5 ml, so on and so forth. And these cartridges, the working is very similar. The working is very similar to the SP, but the only other thing which it does is uh, remove phospholipids, which is not possible with conventional SPE. So there has to be some change in the solid phase. There has to be some change in the solid phase to retain the lipids as well. And what is that? And that is what we are interested in knowing, that in hybrid SP, what other things we have other than the silica which we used in conventional SP. This hybrid SP phospholipid involves a simple protein precipitation step with a fast and robust SP that is customized to remove phospholipids. That means the material is such that it can retain highly selectively all phospholipids. This is very important, and it involves two steps: protein precipitation as well as retaining phospholipids. Phospholipid moiety of the phosphate moiety of phospholipid is a strong Lewis base. And therefore, if we are in a position to give us Lewis acid in the solid phase, and that is done through zirconium atoms. So zirconium atoms are coated on the silica surface, so that which is a Lewis acid. So that Lewis acid combines with the Lewis base, that is the phosphate moiety of the phospholipids, and this helps in retaining or removing the interference of phospholipids. So this whole thing can be seen through this figure. These are the cartridges, similar cartridges which we just saw. And what is more important here is that it has a silica base which has OH groups. This OH is removed, H is removed, and instead of that, what you find here is zirconium atom. Now this is a Lewis acid, and the phosphate group is a Lewis base. So there is Lewis acid Lewis base interaction here, which retains selectively all the phospholipids which are present in a biological samples using this patented technology. So this is known as a hybrid technology, where it removes the proteins as well as the phospholipids. So that is the whole essence of hybrid SP phospholipid technology. Have you understood this much? Have you understood this much? Are you there?
Yes, sir.
Okay. જ્યારે ખબર નહીં પડે તો કહેજો કે શું ખબર નહીં પડી તો શું. I'm trying to explain these complex techniques in a simpler way for you to understand, because this is for the first time that you are being exposed to such techniques and tools which are now available everywhere to separate complex metrics. Richa, is it okay? Smith?
Yes, sir.
Pooja? Yes. Okay. Good. Now there are two techniques remaining. One is solid phase macro extraction and cloud point extraction. These are the last two techniques which remain in unit 2, and I'll be doing these two things little bit in detail, because these are totally new things for you, and hopefully I'll be able to complete it today, this entire unit, so you have some idea about sample preparation techniques, which is one of the heart of any analysis with any instrument which you use of any cost, or with any selectivity features or sensitivity features which it is available commercially. Now, this is solid phase, correct? But instead of extraction, it is micro extraction. Now, the remaining two techniques, like this technique and the other technique, they focus on, their main focus is on green approach. Their main focus is on green approach. What is green approach in analytical science? We want, the first principal thing which we want is, we want to reduce use of toxic organic diluents. This is one major thing which is contributing to the pollution and waste disposal, problems in waste disposal, generation of lot of toxicity in the environment. So there are certain modifications. When you look at solid phase extraction, it requires about 4 to 5 ml and the whole thing is done of organic diluents. But in solid phase micro extraction, it requires 0.1 ml of organic solvent. So you drastically reduce the volume of solvent which you use. This is very important. And this is one area where people have worked so that they can have a technique which follows the principles of green analytic or greenness or green analytical science. And looking at that, this is known as a solventless extraction technique. It is known as a solventless extraction technique. That means इसमें solvent बहुत कम से कम use होता है. 10, 20 times, 30 times less than what one uses in the conventional solid phase extraction. This is the merit of solid phase micro extraction. And then how it happens? This is how the equipment looks like. How it looks like? Now you have a simple device which looks very similar to a syringe. Very similar to a syringe. But it has a needle also, and then it has a rod also. Just after at the end of the needle. On this needle, you have a fiber. This is a polymer thing, which is coated with a solid phase, It doesn't have large amount of, like 30 milligrams you use in conventional SPE, 30 mg in solid phase extraction. But in micro extraction, it will be in less than 1 mg. Less than 1 mg of solid phase you use here. So that is coated here. A fused silica fiber is coated with, this is the fused silica fiber, is coated with a solid adsorbent or solid material, or an immobilized polymer, or a combination of two to prepared in monolithic fibers or thin films. That means, इसका मतलब ये हुआ कि जो ये फाइबर होता है लास्ट में जो आप देख रहे हो यहाँ पे, इस पे ये सॉलिड फेज जो हम यूज करते थे SPE में, that is coated on the surface. And the amount of which is coated is less than 1 microgram. So you use 1 or 2 micrograms, maybe 1 or 2 micrograms of your solid phase in solid phase micro extraction. And you can see the dimensions as well. The typical fiber dimension, ये जो fiber का जो dimension is 1 centimeter length and this much is the thickness. 110 micrometers is the thickness of these fibers. And once we have a system like this, what we can do is we can simply put this syringe kind of a thing into our sample directly. It could be solid, it could be liquid, it could be gas. Now this is a very important feature of SP. What will happen if you put it in a sample which is either solid, liquid, or a gas? Of course, for solid, you might need to heat that sample to generate the vapor of your analyte. You simply dip this rod and the analyte will get adsorbed on the surface of the adsorbent which you have applied on the fiber. And then you can remove this system from that sample. And once that analyte is adsorbed on the surface, you can simply desorb. मतलब उसमें से आप निकाल सकते हो that adsorbed analyte and use it in your analysis. And it is used essentially in gas chromatography. गैस क्रोमेटोग्राफी के अंदर जब हम सिरिंज से गैस का सैंपल, अगर हम कोई सैंपल मतलब गैस के जो इंजेक्शन पोर्ट होता है उसमें हम डालना चाहते हैं, तो ये दिस होल सिस्टम वर्क्स एज अ सिरिंज and just you take this syringe kind of a thing and put it in the injection port of gas chromatography. It will immediately take in the analyte into the system. So there is no need of any extra things involved in sampling in solid phase micro extraction. So that is how it can be. That is how it is. It is that simple. Apparently to extract, but of course the solid phase which you use, which you coat, has to be selective towards the desired analyte. This is important. It has to be selective towards the desired analyte. That is very important. So and now if you look at configurations which are available for solid phase micro extraction, there are different configurations available. Different configuration. You can use a stirrer which has this material. This yellow one is the extraction phase. So you can simply put your sample. This is a syringe, that same syringe with a stirrer kind of a thing, which is coated with your solid phase, the extraction phase. Or you can simply put a disc or a membrane, which is the extraction phase, which is the same material. Or you can use a vessel. You can use a vessel. This is a sample. This is a sample. Green is their sample. Everywhere green is your sample. And yellow is your extraction phase. That is the adsorbent, the solid phase. So it is in different configurations. This SPME can be in different configurations, right? It can be taken as in the walls of the vessel. It can be made in the form of a disc or a membrane. It can be formed in a form of a stirrer. It can be in a form of a particle as well, which is coated with the solid phase. So either way, these are different configurations which are now currently available to extract samples selectively using SPME. Just like solid phase extraction, SP involves processing of an partition from sample matrix to the extraction phase. Again, there is partition from your sample phase to the extraction phase, and it is driven by gradients of the chemical potentials among the sample matrices and the extraction phase. See, there has to be a concentration gradient. जब concentration gradient होता है, एक जगह सब कुछ है, एक जगह कुछ नहीं है, तो जहां सब कुछ है वहां से जहां पे नहीं है वहां पे चला जाएगा. That concentration gradient is created through any of these configurations such that analytes gets partitioned and they get adsorbed on the surface of the solid phase in any of these configurations. जो भी आपने configuration देखी थी, और इसमें जो efficiency मिलती है वो around 95% मिलती है. मतलब you lose 5% of the sample, but 95% it gets extracted. So that is the the beauty of SPME. And this is what I just mentioned. The fiber is exposed to the gaseous or liquid sample or the headspace above a solid. But when you use a solid, you need not have to put it inside the solid, but you can just put above the solid, and then you can little bit heat the sample so that some vapors are generated and those vapors get adsorbed on the adsorbent or the solid phase. So as it is written, samples are often agitated to increase the efficiency. मतलब कभी हमें गर्म भी करना पड़ता है, कभी हमें shake भी करना पड़ता है sample को, so that extraction efficiency increases. And once it is extracted, you remove, and then you can directly desorb into a suitable system thermally. गर्म करोगे वो निकल जाएगा, चला जाएगा. So it can be directly injected, जैसे इसमें लिखा है, into the gas chromatograph. So there is no need of further sample preparation. That is the importance of solid phase extraction. It minimizes the steps in solid phase extraction. It utilizes very small amounts of adsorbent, and it is essentially organic solvent free. Very small sample is required. I said 20 times, 30 times less than what you use in conventional SP. That is the importance of solid phase extraction. And these are the features. The absolute recoveries are often extremely low. However, very satisfactory can still be achieved when coupling SP with chromatography. And this is the most important thing, is that it is a green sample preparation technique. So when we talk about green sample preparation technique, this is one such technique which is in use as of now worldwide because of environmental concerns. Solid phase micro extraction. So with very good efficiencies. What I am telling you is a preliminary kind of information about solid phase extraction. In more advanced solid phase micro extraction, the efficiency is even higher than 95%. So this was all about solid phase extraction. And now coming over to the last extraction technique, which is also a green analytical technique. The basic intention of this technique, which is known as cloud point extraction for separation and pre-concentration. See, these two things are very important in extraction: separation and pre-concentration. And this is also done by liquid extraction, countercurrent extraction, solid phase extraction, and even solid phase micro extraction. These are the salient features of these techniques. But this technique does something else as well. It follows the principles of green chemistry by eliminating completely the use of organic solvents. So the major crux in using or in developing an analytical method is to somehow remove the use of toxic organic diluents. That is what was done with SPME, and this is what is done with CPE, cloud point extraction. Now, what is it? Cloud point extraction is a separation and pre-concentration procedure that has been extensively applied for trace metal determination in several different matrices. It is used for separating, extracting trace metal ions, जिसका concentration 0.01% से भी कम हो, उसके लिए cloud point extraction is one such technique. It is being used in varieties of fields, in food analysis, in pharmaceutical analysis, in some environmental samples. At many places you will find cloud point extraction. The major advantages are simple experimental setup, low cost, high pre-concentration factor. That means it can pre-concentrate to a very large extent. Concentration बहुत कम है तो ये ज़्यादा कर देगा. That means it can take up in small volume without using organic solvents. Without using organic solvents. And of course, when it doesn't use organic solvents, it helps in environmental safety. So that is what. Now it is also being used for separating organic molecules. Previously it was for metal ions. Now it is also used for organic solids. So this is very important here. The use is now extended to organic solvents and trace metal determination. CPE is, as I said, is a green method for the following reasons. It uses an extraction media, diluted solutions of surfactants. So instead of solvents, it uses surfactants that are inexpensive. That means you have economical benefits and minimum residues or unwanted things coming out of this. Surfactants as such are non-toxics. They are non-volatile. The major problem of organic solvents is their volatility. But surfactants are non-volatile and not easily flammable. Not easily flammable, just like organic solvents or organic dilutants, which are used in liquid extraction. I just have 12 more slides, but these are very simple slides which I have prepared just to give you an idea about what is cloud point extraction. CPE is the most widely used in a family of surfactant based methods, and this was introduced way back in 1976. At that point of time it was introduced, and at that point of time it was used exclusively for metal ions. But now, as I said, it has been significantly modified to separate organic molecules as well, covalent molecules as well. Now, the process, what happens? The cloud point procedure is based on the following phenomena. An aqueous solution of some surfactant becomes turbid and separates into two isotropic phases if some conditions such as temperature or pressure is changed or if an appropriate substance is added to the solution. कहने का क्या मतलब है कि जो आपका सैंपल होता है उसमें आप थोड़ा सर्फेक्टेंट डाल दो तो क्या होता है, सर्फेक्टेंट खुद का एक डिस्टिंक्ट फेज बना लेता है. सर्फेक्टेंट आपको मालूम है क्या होता है. You have a hydrophilic component and a hydrophobic component in a surfactant. So the advantage of this property of surfactant is taken in cloud point extraction. Because you are extracting from an aqueous phase, the component which is ionizable, which is hydrophilic, takes something from the aqueous phase and then put it inside its hydrophobic cavity, hydrophobic structure, so that it extracts it from aqueous phase without use of any organic solvent. This is the beauty of cloud point extraction. And surfactant becomes turbid because it attains a cloud point. That means अगर आप surfactant लेते हो पानी में और थोड़ा गर्म करते हो तो cloudy हो जाता है. उसको हम बोलते हैं missile formation. What is missile? उसके बारे में अभी आएगा. That means it tries to form a distinct phase in water itself. वो एक अलग phase बना देगा. This is a very simple experiment which anybody can do in a lab, that you can add some surfactant to water and then you heat it and then you cool it for some time. You will find two phases. One is the surfactant phase and the other is the aqueous phase. And in this, if there is some analyte in the aqueous phase, that would be taken into the surfactant phase. That is the whole essence of cloud point extraction. And then you remove the surfactant phase and then use it for any kind of analysis using any equipment, starting from spectrophotometry to any other technique which you have. So basically it forms a missile. जो cloud हो जाता है, जो cloud बन जाता है, वो cloud किसका होता है? Micellar structures हो जाते हैं. What is micellar structure? That will come later on. अब इसके कुछ features हैं. The small volume of surfactant-rich phase obtained with this approach permits design of extraction strategies that are simple, inexpensive, and highly efficient when compared to those extractions that use organic diluents. This is important. The efficiency of extracting any analyte from an aqueous phase using surfactants is much higher as compared to the organic solvents which are used conventionally in different extraction procedures. मतलब कि जो extraction efficiency है surfactants की is much better as compared to using organic diluents which is present in other solvent systems, which is present in other organic solvents. The main limitation, however, is the relatively low partition coefficient of several metal species with determinate chelates. मतलब कि क्या होता है कि मेटल आयंस को एक्सट्रैक्ट करना थोड़ा टफ रहता है. तो उसके लिए क्या होता है कि जब हम कॉम्प्लेक्स बनाते हैं उसमें हम कीलेट डालते हैं, मतलब एक कीलेटिंग एजेंट डालते हैं उसी सैंपल के अंदर, तो मेटल से कीलेट बनाएगा. लेकिन कभी कभी वो कीलेट इतना स्टेबल नहीं रहता उस सरफेक्टेंट फेज में, तो उसके लिए हम कुछ डालते हैं जो कि हाइड्रोफोबिक नेचर, so that there is a hydrophobicity created in that system so that substance is retained in a distinct phase. The analyte is retained in a distinct phase, अलग phase में. और जो advantage है SPE का, वो as I said high pre-concentration factors. That means अगर आपके पास 50 ml सैंपल है तो आप उसको 5 ml सरफेक्टेंट में ले सकते हो. 10 times you can pre-concentrate. अगर कोई चीज 100 ppm थी तो आप उसको 1000 ppm बना सकते हो. मतलब इतना ज्यादा pre-concentration factor आप उसका ला सकते हो, and which is higher compared to SPE और LLE. क्योंकि SPE में ये करना और LLE में ये करना it is not feasible. एक फेज आप 5 ml लो और दूसरा ml 50 ml लो. It is generally not done. But in cloud point extraction, you can take 50 ml of sample and then you can make a phase of 5 ml of surfactants. So you increase 10 folds the concentration. So this is one of the major advantages of ye. And this can be done in as small volumes as 0.2 to 0.5 ml. Now you see, this is the surfactant phase. This is one of the very important aspect that in SPE when you compare it with other phases. अगर आपके पास 10 ml है कोई चीज सैंपल तो आप उसको 0.2 ml में ला सकते हो. So now you can understand कितने times you have reduced the volume and thereby the pre-concentration factors. 10 ml था उसमें से 0.2 ले आए, 50 गुना आपने उसको ज्यादा pre-concentrate कर दिया. That is the whole beauty of cloud point extraction. Now I was talking about missiles. These are the missiles. ये है surfactant molecules. Surfactant molecule. इसका ये है ionic part, ये है non-ionic part और hydrophobic part. इसका एक concentration होता है. जब surfactant का concentration इतना हो जाता है कि वो ऐसा बना लेता है जिसको हम बोलते हैं critical micellar concentration, CMC, critical micellar concentration. That means ये सारे जो components हैं वो हाइड्रोफिलिक हैं और जो अंदर वाला पार्ट है वो हाइड्रोफोबिक है. इसको हम बोलते हैं मिसिल और मिसिल्स which have a hydrophobic tail. ये हाइड्रोफोबिक टेल्स है इनके, और ये हाइड्रोफिलिक heads and hydrophilic tail, hydrophobic tails. This is hydrophobic in nature, the center thing, and the outside thing is hydrophilic heads, and these are the tails. And जो भी एनालाइट होता है जो हम पानी में से लेते हैं वो इसके अंदर ट्रैप हो जाता है, इसके अंदर ट्रैप हो जाता है और एक अलग फेज में चला जाता है, इसको हम बोलते हैं मिसल। तो ये मिसल बनने से हम इसको सेपरेट कर सकते हैं। And this is known as I said, critical missile concentration. And this is achieved by adding adequate amount of surfactant monomer. Adequate amount. एक कॉन्सेंट सबका अलग अलग होता है, हर सर्फेक्टेंट का अलग अलग होता है। कितना कॉन्सेंट्रेशन डालोगे कितने पानी में तो उसका कॉन्सेंट्रेशन वुड रीच CMC. If that is reached, and if you just heat the sample for some time, and then you allow it to cool down, you will find two phases. This is as simple as that. Then missiles can be of different shapes, but generally they are spherical in nature, spherical in shape. They are spherical in shape. So that is how, I mean, cloud point extraction works. This is all about what I've just mentioned to you, that it has a hydrophilic head and hydrophobic tail, and it forms a missile. And this is how it happens. Actually, the experiment, you have original solution with A is the original solution with metals. This is with metals in very low concentration. Then what you add a chelating agent. So obviously the size would become bigger. The metal chelates formed by addition of complexing agent in the sample solution or the sample matrix. Then you add surfactant such that the concentration is above the CMC, critical missile concentration. तो ऐसा स्ट्रक्चर बन जाएगा, इसके अंदर ये सब चीजें चली जाएंगी, ये जो कीलेट्स हैं वो इसके अंदर बैठ जाएंगे। बैठ गए अंदर, उसके बाद तुम इसको हीट करो। जब हीट करके ठंडा करोगे तो तुम देखोगे, और सेंट्रीफ्यूज भी कर सकते हैं, you can find a distinct phase which is known as surfactant phase, जिसमें सारे extraction analyze अंदर आ चुके होंगे, and then you will have free, you will have a solution, aqueous solution, which will contain the monomer of surfactants, the monomer, few monomer of surfactants which are there in this aqueous medium. But you get a distinct phase in the surfactants phase where the analyte of interest is entrapped, or here it is metal ions. So there are three steps. Creating a missile by adding a surfactant, increasing the temperature to above the critical, cloud point temperature, which is known as temperature above which there is a cloud formation. That means there is missile formation. And then when you cool it down or you centrifuge it, it will form a distinct phase. एक phase बन जाएगा, phase separation हो जाएगा, and which can be removed, decanted or centrifuged. So this is what is all about. But there is a choice of surfactant which are used. It is said that the non-ionic surfactants are supposed to be used. Only the non-ionic surfactant, because if there are ionic surfactants, what will happen? They will try to remain in the aqueous phase because it is ionic. So essentially it should be non-ionic, and for that to happen, these are the polyoxyethylene based surfactants, and the commercial name is Triton X100, Triton X114, Bridge 30, 35, 56, 97, having different temperatures for critical point, for cloud point temperature. CPT is cloud point temperature, which is 2 degrees centigrade, 100, 69, 70, depending upon the type of surfactant which you use. So these are the common surfactants which are being used to form, the distinct phase in cloud point extraction. And as I said, it finds applications in so many areas And it can be, see, the extraction of priority pollutants from water, solids and biological samples has been done. That means for removal of pollutants in water, one can use cloud point extraction. It has removed phthalates. This is very important. Toxic polycyclic aromatic hydrocarbons, biphenyls, chlorinated compounds, organochlorine pesticides can be removed from samples using cloud point extraction. And it is also being used at other places in removing certain toxic things present in milk, herbicides present in milk, atrazine, cyanazine, simazine, cimetrin. These are certain herbicides which can be removed from milk, which is aqueous sample, with Triton X100. Of course, and then one can, this is the process, That means what pH you need to adjust and what should be the temperature and so on and so forth. And then once they are separated, they can be, as I said, it can be analyzed by any known technique like HPLC or UV visible spectrophotometry. Anything can be used to determine their presence, their concentration. And they have very good detection limits also. 5 to 10 milligram per liter, that means 5 to 10 ppm are generally the limits for these herbicides in milk, and the recoveries are 70 to 97%. Recoveries are also good, and it is also being used in pharmaceuticals. I mean, there are many examples. I have just taken a simple example of benzodiazepines and lorazepam, with recoveries and very good, which there are certain things which we need to do to extend the recoveries as well. Here you can find the recovery was very less, but it can be further optimized to increase this efficiency of extraction, because everything may not be extracted to the same extent. As you can see, elaprazolone LM is 67%. So different drugs are extracted to different extent. And then of course one can go for any instrumental analysis to know their concentrations, etc. So cloud point extraction, if we summarize, is that it is basically a solvent-free technique. It adheres to the principle of green chemistry. It doesn't use toxic organic diluents. At the same time, it uses surfactants. It uses surfactants for creating a different phase. And for every surfactant, there is a different cloud point temperature, and there is a amount which one needs to take so that CMC, critical missile concentration, is reached. And by agitation or by increasing the temperature, one can create a distinct phase. And that phase separation can be done by cooling simply or by centrifuging the sample, and then recovering that surfactant phase, and then analyzing the contents or the analytes present in that sample. So this was all about the different sample preparation techniques which I wanted to share or discuss with you in this unit 1 in semester 2. So if you have any questions related to any of these techniques, I'll be sharing this presentation tomorrow to all of you, so you can have a look at the presentation, and I'll be sharing in due course the MCQs which we have been preparing. That also will be shared with you. We can upload it on your MS Team, and so you can see. And if you have any query or question or suggestion, you are please most welcome. So that is what I wanted to tell in this unit. Anyone, Smith or whosoever is there? Jaspina, Patel, Gopi Mahendra Bhai, Richa, Smith Patel, I can see your name. Charmi, Heenal, Anyone? Dinky, are you there?
Yes, sir.
Okay. तुमने खबर पढ़ी? Okay.
Yes, sir.
ठीक है. सी मेरा इंटेंशन ये था इस यूनिट से कि दिस इज बिफोर यू गो फॉर एनी एनालिसिस ना, रियल सैंपल्स की मैं बात कर रहा हूँ, you need to do something that is known as sampling and sample preparation, and this is one of the bottleneck in any analysis. कोई भी इंस्ट्रूमेंटल एनालिसिस इसके बगैर नहीं हो सकती. I have listed 5-7 extraction procedure. There are 3-4 more advanced ones which I have not taken in your syllabus because I don't want to overload you with different techniques. And that is all which you will find in literature as of now, 2021. In any field. There are 3-4 more which I have not included in the syllabus, which are slightly semester 3 and 4. So I want to keep the thing simple, and I have prepared these slides to make things very simple, and so that you can read and understand on your own and prepare yourself for your exams whenever they happen, or if they don't happen, whatever may be the case. But at least you should be aware of these sample techniques are available now, and people have been using this, or they are in current use everywhere worldwide. तो अगर आपको कुछ पूछना है या कुछ मेरे से कुछ कहना है या कुछ बात करनी है या कोई कंफ्यूजन है तो आप मेरे से बात कर सकते हो. एनीथिंग. आपको ये होगा, आप बोल नहीं रहे हो, लेकिन जैसे मैंने सेमेस्टर GIA में पूछा था तो उनको बहुत सारी चीज़ें थी कि हमारा इंटरनल कब होगा, हमारा 15 को होने वाला है, और लेक्चर होंगे कि नहीं होंगे वैकेशन में, फिर हमारा मेरिट बेस्ड प्रमोशन का क्या है, कब पता चलेगा. आई थिंक दीज आर द थिंग्स विच पीपल आस्क मी इन GIA. आई थिंक ये सेम चीज आपकी भी होगी.
Yes, sir.
Yes, sir.
हाँ, आई नो आप बोल नहीं रहे थे, लेकिन मुझे तो पता है आपके दिमाग में चल क्या रहा है. तो मैं आपका हर एक चीज का एक एक आंसर दे दूं. पहली चीज कि आपका जो मेरिट बेस्ड प्रमोशन की जो बात है उसका कोई ऑफिशियल लेटर या परिपत्र हमारे पास नहीं है एज ऑन टुडे 5 मई 2021. तो जब तक नहीं आता तब तक हम यही समझते हैं कि नहीं है. जिस दिन आ जाएगा उस दिन समझ जाएंगे कि नहीं है. तो वो बात तो मैंने क्लियर कर दी कि किसी के पास भी नहीं है अभी कोई परिपत्र. सो वन थिंग इज क्लियर. सेकंड थिंग, लेक्चर आप ले रहे हो, वेकेशन में ले रहे हो, और ऐसा क्यों कर रहे हो? सब लोग तो नहीं ले रहे, कुछ लोग ही ले रहे हैं, 2-3 लोग ले रहे हैं, ऐसा कहा गया था मेरे से GIA में. तो वही चीज मैं आपसे दोहरा रहा हूँ. हाँ तो ठीक है, हाँ ले रहे हैं, ठीक है हम ले रहे हैं. और आप पूछो क्यों ले रहे हैं, मेरी सोच थोड़ी सी अलग है, वो मैं आपको मैं बता देता हूँ. देखिए आपका अभी तक बेसिकली कुछ भी नहीं हुआ है. कुछ भी नहीं हुआ है मतलब शायद कुछ बच्चों ने प्रेजेंटेशन और सेमिनार असाइनमेंट कर लिया है. आई थिंक मेरे वालों कुछ ने कर लिया है, कुछ 1-2 बचे हैं, 2-3 बचे हैं. नहीं सॉरी, आप लोग तो HPPO, आई एम सॉरी, आपका तो कुछ नहीं हुआ होगा, तो अभी वो भी बाकी है. आपका अगर इंटरनल होता है तो उसका थ्योरी भी बाकी है, प्रैक्टिकल भी बाकी है. उसके बाद अगर एक्सटर्नल होता है तो उसका थ्योरी भी बाकी है, प्रैक्टिकल भी बाकी है. प्रैक्टिकल सबका बाकी है, सब कॉलेजेस का. मतलब समझ लेना कि अराउंड 1000 स्टूडेंट्स जो सेमेस्टर 1 में थे वही सेमेस्टर 2 में आएंगे. और ये सारा काम करने के लिए कितना समय लगेगा आपको बताऊं? 1 महीना, 1 मंथ. क्योंकि ऐसा तो होता नहीं है. और ये जब भी अगर होता है, सपोज आपका मेरिट प्रमोशन हो जाता है, वेल एंड गुड, फाइन. अगर नहीं होता है तो आपको पता है क्या होगा? थ्योरी इंटरनल, 2 दिन के गैप के बाद प्रैक्टिकल इंटरनल, 2 दिन के गैप के बाद थ्योरी एक्सटर्नल, 2 दिन के गैप के बाद प्रैक्टिकल एक्सटर्नल, जो कि लंबा चलता है, 10-15 दिन चलते हैं, क्योंकि सारे कॉलेजेस के लेने होते हैं। तो ये होल प्रोसेस चलेगा ना, बैक टू बैक चलेगा अगर होता है तो, फॉर 1 मंथ। और अगर हम ये 6 जून तक हम ये पढ़ाना बंद कर दें, मान लो एक समय के लिए बंद कर दें, तो ये कोर्स तो बाकी रहा, तो एग्जाम लेने के पहले मुझे कोर्स खत्म करना पड़ेगा। तो कोर्स खत्म करने के लिए 10-15 दिन और चाहिए होंगे, और 1 महीना लगेगा एग्जाम होने में, तो 1.5 महीना तो मुझे और चाहिए। और अगर 1.5 महीना इसमें लगता है तो वी हैव रीच मिड जुलाई। उसके बाद 15-20 दिन लगेंगे रिजल्ट लाने में, तो आ गया अगस्त। अब जब अगस्त आ गया, तब आपको मुझे ये बताओ कि आपको सेमेस्टर 3 में टाइम कितने महीने का मिलेगा। मैं नहीं समझता 1.5 से 2 महीने से ज़्यादा मिलेगा। और होगा ये, फिर से वही आ जाएगा कि सेमेस्टर 3 का इंटरनल एंड सेमेस्टर 3 का प्रैक्टिकल इंटरनल, फिर इमीडिएटली एक्सटर्नल, और फिर प्रैक्टिकल एक्सटर्नल, so that you are supposed to move into semester 4। मतलब ये साइकिल है ना, टूटेगा ही नहीं, ये चलता ही रहेगा, और ऐसे करके करके मुझे लगता है आप सेमेस्टर 4 भी कर लोगे। तो इसको देखते हुए ऐसा मुझे लगा, ऐसा मेरा पर्सनल ओपिनियन है, किसी ने मुझसे कहा नहीं है, ये मैं खुद कह रहा हूँ, ऐसा मुझे लगा कि अगर मैं कम से कम थ्योरी कंप्लीट हो जाती है आपकी, तो मुझे 15 दिन मेरे बच जाएंगे बाद में, मुझे सिर्फ एग्जाम लेना रहेगा। अगर एग्जाम होता है तो ये फर्स्ट कंडीशन। सेकंड कंडीशन, अगर एग्जाम नहीं होता है, ठीक है, तो कम से कम आपने पढ़ तो लिया, जो आप पढ़ने आए थे सेम 2 में वो पढ़ तो लिया, कभी ना कभी कहीं ना कहीं काम तो आएगा। खाली बैठने से अच्छा कुछ पढ़ लिया, एग्जाम नहीं हुआ, एग्रीड, वो टाइम हमारा बच गया। अब आएगा एडमिशन प्रोसेस, तो आपका एडमिशन भी फटाफट हो जाएगा, टाइम भी बच जाएगा, क्योंकि नो एग्जाम्स, कोई एग्जाम्स हुए ही नहीं, तो कुछ नहीं होगा, ठीक है, बच जाएगा। तो कहने का मतलब ये है कि अगर एग्जाम नहीं होता है तो इट इज़ बेटर कि थोड़ा बहुत पढ़ लो और जून में सेमेस्टर 3 में चले जाओ। और एक एग्जाम होता है, इंटरनल एक्सटर्नल सब होता है, तो आप समझ रहे हो कि कब तक चलता रहेगा ये काम। यू विल रीच, आई एम टेलिंग यू, एंड ऑफ जुलाई रिजल्ट आते आते, या मे बी अगस्त भी घुस जाए, अभी आई डोंट नो। तो ये मेरी पर्सनल थिंकिंग है, इस वजह से मैं लेक्चर्स, जैसे मेरा एक यूनिट हो गया है, प्रैक्टिकल हो गया एनालिटिकल में, एंड आई एम सपोज टू कंप्लीट 1 यूनिट, तो मैं आपसे उतना ही मैं आपको डिस्टर्ब करूंगा जब तक मेरा दूसरा यूनिट खत्म हो जाएगा। जैसे ही खत्म हो जाएगा मैं आपको छोड़ दूंगा मेरी तरफ से, और जो भी ले रहे हैं वो ले रहे हैं, मतलब हम उनको, मतलब इट इज़ ओके। और जो नहीं ले पा रहे हैं, या जो भी किसी की कोई मजबूरी है या कोई प्रॉब्लम है, तो दैट इज़ फाइन। और खाली बैठने से अच्छा तो, और गैप हो जाएगा तो बाद में आपको पता ही नहीं चलेगा कि एनालिटिकल केमिस्ट्री क्या होती है, ऑर्गेनिक केमिस्ट्री क्या होती है, फिजिकल क्या होती है, और फिर सब कुछ नया नया लगेगा। तो वेकेशन है, कहीं घूमने तो कम ही लोग जा पाएंगे, क्योंकि घूमने जैसा वातावरण भी नहीं है, और कहाँ जा सकते हैं, तो कभी कभार 1-2 घंटे सुन लो कुछ, ये थॉट प्रोसेस से आई होप आई हैव आंसर्ड मोस्ट ऑफ द थिंग्स विच यू वांटेड टू आस्क। एनीवन कैन रिस्पॉन्ड। मैं बोले जा रहा हूँ, कुछ तो रिस्पॉन्ड करो।
Yes,
Yes,
sir.
sir.
We can answers for your question, our questions.
यस, आप स्पीक बोलो। यस,
ये सारे आंसर मिल गए जो हमें चाहिए थे।
मिल गए ना, बस मेरे को
Thanks.
यही है, मेरा यही है कि बस ये मेरी थिंकिंग है, मेरे को किसी ने ना डायरेक्शन दिया है, ना किसी ने मेरे को कुछ बोला है, ना मेरे पास कोई लिखित परिपत्र है, कोई इन्फॉर्मेशन नहीं है, लेकिन मैंने अपनी बुद्धि से ये सोचा कि मैं आप लोगों को सही तरीके से गाइड करना चाहता हूँ, और मैं आपको जो आपकी क्वेरीज है उसको डिसमिस नहीं करना चाहता, उसको मैं लेके उसको शेयर करके उससे कुछ सही चीज़ निकले, वो मेरा एम है। मेरा एम सिर्फ इतना ही है कि आई वॉन्ट टू पुट यू ऑन द राइट ट्रैक, बिकॉज तुम यहाँ एमएससी करने आए हो, खाली टाइम पास करने नहीं आए, तुम पढ़ने आए हो, तुम स्कूल ऑफ साइंस में आए हो। और हम सब कुछ अच्छा तो नहीं कर पा रहे हैं, लेकिन जो भी कर पा रहे हैं, जितना भी कर पा रहे हैं, जितने समय में कर पा रहे हैं, वो हम करना चाहते हैं। ये हम, मेरा तो पर्सनल यही एम है। एंड आई वांट टू एड्रेस योर क्वेरीज, मेजॉरिटी ऑफ द क्वेरीज, इफ इट इज पॉसिबल फ्रॉम माय साइड। देखिए, मैं हेड ऑफ द डिपार्टमेंट नहीं हूँ, हेड हैं जेंसर हैं, एंड ही विल बी हैविंग some answers to your questions. I don't know, but since I was asked by GIA students, तो मैंने सोचा था कि मैं HPB स्टूडेंट्स को भी, एक्चुअली में मुझे ये उसी दिन बताना था आपको शाम को, बट मेरी कनेक्टिविटी का, जैसे मैंने बताया, बिल्कुल मेरा कनेक्शन आ ही नहीं रहा था। आई कुड नॉट शेयर ऑन दैट डे। सो मैंने सोचा ही था कि मैं आज के दिन आपसे मैं ये ज़रूर बात करूँगा, क्योंकि आप बात करें ना करें, बट मैं आपको ज़रूर एक जो मेरी सोच से उसको बता दूंगा, एंड दिस इज़ व्हाट आई डिड। सो थैंक यू, तुम लोगों ने मुझे, यू लिसन टू मी एंड होप यू अंडरस्टूड what I wanted to convey. And I find you people are really matlab mature and understanding when I speak to you, and you also think on the same way, the way in which I think. So that is a very good thing which I observe in you. And some of the students are very eager to, study. I know, because I get some reviews, so from my students, etc., who are teaching you, and others as well. Okay, they are very, I mean, attentive. They are very good. So what I feel is that if you are really, interested, and you are that enthusiastic to learn, I think I should guide you, and I should suggest the best I can for you. So with this, if you have no further queries, I'll just
Sir,
stop. हाँ, पूछो 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 बाबा, पूछो।
sir,
Yes.
any tentative dates for results of SAM 1?
हाँ, चलो अच्छा है। सॉरी, मिस रिचा ने मेरे से एक सवाल पूछा है कि एनी टेंटेटिव डेट्स फॉर MSc सेम 1 रिजल्ट्स। देखो, ऐसा है कि द मार्क्स for of MSc semester 1 chemistry were submitted to the university 1 week back, last week of April, complete in all respects. First thing. Second thing, the university declares the results when they receive results from all the departments like physics, maths, stats, zoology, botany, forensic science, etc., life science, etc. When they get the results from everyone, then they declare the results. This is one hindrance in declaring the results of chemistry now. Though they have very few students in, I mean, सारे डिपार्टमेंट के जितने भी कैंपस में हैं, डिफरेंट डिपार्टमेंट्स के तुम स्टूडेंट्स मिलाओगे, तो वो केमिस्ट्री का जो हमारे 250 स्टूडेंट्स हैं, उतने भी नहीं हो पाएंगे शायद। बट अभी तक कईयों के रिजल्ट्स बन के यूनिवर्सिटी में सबमिट नहीं हुए हैं। एंड देयरफॉर, जो तुम्हारा सवाल था उसका आंसर ये है कि व्हाट आई एंटिसिपेट, at least not before 15th, at least not before 15th. Richa.
Yes, sir.
So this is what I can, based on my experience, कि कैसे रिजल्ट बनता है, बिकॉज वहां जाने के बाद भी इसमें प्रोसेसिंग होती है। तो आई फील के मुझे डाउट है कि 10 दिन में आ जाएगा, क्योंकि सब डिपार्टमेंट्स का अभी तक नहीं गया है, एंड दे डिक्लेयर इट व्हेन दे गेट फ्रॉम ऑल। तो यू हैव टू वेट एटलीस्ट 10। मैंने ये नहीं बोला कि 15 को आएगा, ये नहीं बोला 16 को आएगा, मैंने ये बोला 15 तक तो शायद नहीं आएगा। उसके बाद if everything goes well, people there who are working, they are infected, I mean they are healthy, etc., then आ सकता है। अगर उसमें से कोई प्रॉब्लम में आ गया है या कुछ ऐसा इश्यू है, तो फिर शायद और भी डिले हो सकता है। बट केमिस्ट्री का रिजल्ट जा चुका है, दैट मच आई कैन अश्योर यू। सो ठीक है, थैंक यू वेरी मच एवरीवन। किसी का हाथ उठा भैया, हाँ बोलो बोलो।
हेलो सर।
हाँ श्रेयांश।
सर हम पानी का इलेक्ट्रोलिसिस हम करते हैं
हम्म,
तो ऑक्सीजन और हाइड्रोजन मिलता है ना, कैथोड पे हाइड्रोजन और एनोड पे ऑक्सीजन।
हम्म।
तो सर वो ऑक्सीजन हम प्रेशराइज करके सिलेंडर में भर के यूज कर सकते हैं क्या?
देखो तुम्हारा जो थिंकिंग है वो बहुत ही अच्छी है कि इस तरीके से किया जा सकता है। सी अब देखो श्रेयांश, ऐसा लोगों ने बहुत पहले किया है, मतलब ठीक है, और ये चीज जनरेट करने की कोशिश की है। इसमें क्या क्या इश्यूज आते हैं वो मैं आपको सिर्फ बता रहा हूँ। हो सकता है यू आर राइट जो तुम कर सकते हो। तुम्हारा कंसर्न देखते हुए मैं तुम्हें थोड़ा सा एजुकेट कर देता हूँ कि आपने ये कर लिया, आपने उसको किसी तरीके से प्रेशराइज भी करके कर लिया, ये भी हो जाता है। ये सारे प्रोसेस की जो इफिशिएंसी है ना, जो इफिशिएंसी है वो ऐसी है कि जो फाइनल जो कॉस्ट होगा ना थ्रू दिस प्रोसेस वुड बी ह्यूज, which cannot be compared with the gas which you find in cylinders available, जो आजकल चल रहा है। जो एक सिंपल प्रोसेस है वो हम एयर में से कैसे निकालें, कन्वर्टर जो कमर्शियली अवेलेबल है। तो जो तुम्हारी जो जो क्वेश्चन है वो केमिकली फिजिकली वायबल है, मतलब है, पॉसिबल है, बट इकोनॉमी वाइज, इफिशिएंसी वाइज उसकी जो कॉस्ट है दैट इज ह्यूमंगस। सो प्रैक्टिकली इट इज नॉट वायबल, मतलब कॉमर्शियली इट इज नॉट वायबल। लेकिन हो सकता
Okay.
है, ये बात तो तुम्हारी आई 100% आई एग्री टू इट, बिकॉज पीपल हैव बीन थिंकिंग अबाउट हाउ टू हेल्प पीपल थ्रू एनी ऑफ दिस प्रोसेस। और मतलब this is it, I mean this is the status. You are right. IIT Mumbai people have prepared an equipment, but then that is slightly different.
Okay sir, thank you.
Okay, Shaz. So किसी को और कुछ पूछना है? We will be meeting again on next Monday, I mean Mondays and Wednesdays as we meet. और मुझे ऐसा लगता है कि अगर हम थोड़ा ज़्यादा कर सकते हैं तो we can finish fast, so that you will be free from my side as far as possible. तो ठीक है, so we end up here. I'll stop the recording.